This is Maple TA Lesson 11B, homework question number 2. Solve the following independent system of equations. So it was nice that they told us it's independent. That tells us right at the beginning that I will find a solution. If I were trying to solve these and I ended up with the same numbers for both equations, then I would know that it was dependent and that I would have infinite number of possibilities. And if I ended up with the same equation but a slightly different y-intercept, then I would know that these two are parallel lines because the slope would be the same and the y-intercept is different, and then it would be an inconsistent solution or inconsistent system, and there wouldn't ever be a solution because the two parallel lines would never intersect. So the first thing I'm going to do is go through the substitution method, and being the rebel that I am, those of you who want to try a different method that is not discussed in your textbook, I'm going to kind of hint on the elimination method just because. Those of you who would not like to go any further, and you can just stop the video after we finish the substitution method. But those who want to skip forward and find another kind of fun way to solve these, you can kind of go halfway through and find the elimination method. All right, so the substitution method, I'm going to take one of these equations and solve it for either x or y, it doesn't matter. And since the top one looks fine, let's just go ahead and use that one. So I'm going to take this one here, and let's solve for x. Why not? Just because. So I want to get rid of everything on the left-hand side of the equation. So I'm going to add 6y to get rid of it on the left, and because I'm doing it on the left-hand side, I have to do it to the right-hand side so that the equal sign stays balanced. And I'm left with 3x, negative 6y plus 6y is 0, and then I have positive 6y minus 42. All right, now I need to divide everything by 3 so that x is all by itself. So the left-hand side, divide by 3, and divide every single term by 3. Divide by 3. So on the left-hand side, 3 divided by 3 leaves me with 1, or x. 6 divided by 3 is 2, so I have 2y. Then 42 divided by 3 gives me 14 minus 14. There we go. And then I'm going to take this value for whatever I solve for x and take the other equation. Don't take the same equation or you'll just end up with like 0 equals 0. So I take this and I substitute it into every time I see x in the second equation, or whatever equation you haven't solved for. So Control V, then x here, and I'm going to put in the parentheses. Every time you see the x, make sure you put parentheses so that all of it goes in for x. So then I'm going to take all of this and paste it in here and solve for, in this case, y. So on the left-hand side, I have 7 times this, all of this, which takes the distributive property. So I'm going to take 7 times 2y and 7 times 14. So 7 times 2y gives me 14y. Negative 14 times 7 is negative 98. And then I still have this negative 3y and equals, I haven't done anything to the right-hand side, so it just equals negative 10. Okay, on the left-hand side, I'm going to combine all of the y's. I have 11y minus 3y, and that's 11y. I still have this negative 98 and the negative 10. Okay, now to continue solving, I need to add 98 to both sides. There we go. And negative 98 plus 98 equals 0. So I'm left with 11y equals a positive 98 and a negative 10 makes a positive 88. And then to continue solving for y, I need to divide both sides by 11, which leaves me 11 divided by 11 is 1, and 1 times y is just y. So on the left-hand side, I'm left with, oops, just make it look nice, y equals 88 divided by 11 is 8. And then I need to continue solving for x. So I'm going to go up to the top, and either equation will work for this one, except that I already have this one right here solved for x. So it's kind of nice. I don't have to do any more solving on these. I could go up here and do either of those. It doesn't matter. But this one's super easy, so I'm going to do this one. And again, every time I'm substituting, I'm going to put in parentheses. And in this case, I only have one number, so I'm going to put in the 8. 2 times 8 is, oops, come out of that. And then I have x equals 2 times 8 is 16. 16 minus 14 is 2. And that tells me that my ordered pair, where these two lines will intersect, is x equals 2, y is 8. So the ordered pair 2, 8. And I can put that over here, 2 and 8. And then just for the confirmation, to have the green check marks, that's good. Okay, for those of you who'd like to learn the elimination method, this is not discussed in the textbook. It's just kind of another method to go through it. You do not have to do this way. Sometimes it's faster, sometimes it is more complicated. So the trick is, if I can see that one of the coefficients before the x or the y are easily changed by multiplying something so that they're the exact same, then I can move forward. In this case, I see that this y here has 6 and a 3, and if I multiply the 3 by a 2, then it's the exact same. And I also want the opposite sign. So this one's negative and this one's negative. So I'm going to multiply this one by a negative 2, so it makes it a positive 6, and I'll show you why. And when I'm multiplying this, the y by a negative 2, I actually have to multiply every single term so that it keeps the equal sign balanced. So I'm going to multiply everything here by negative 2, and I'm going to show that by putting parentheses, just like that. So negative 2 times 7, because I'm using the distributive, gives me negative 14x. Negative 2 times negative 3 gives me positive 6y. And negative 2 times negative 10 makes a positive 20. Now, the reason I did that is because this equals this, and this equals this, and I can go ahead and add these together because they're balanced. So I'm going to add these two equations, and so negative 14x plus 3y gives me negative, you know what, let's underline this so that you can see that I'm adding these, and that's kind of like an addition sign here, like this. Okay, so then I end up with negative 11y, or x, and we don't want this one underlined because that top one shows that I'm adding like those two equations. So I have negative 11x. Now I have a positive 6y and a negative 6y, which when I add are gone, and that was the goal here, because now I only have 11 here. And then I'm going to add positive 20 and negative 42, which gives me negative 22. And to solve for x, I divide both of these by negative 11. Divide by negative 11. Divide by negative 11. And then I get x equals negative 22 divided by negative 11 gives me positive 2. And then I go back to any of the equations at the beginning and substitute x for 2 and solve for y. Because this one doesn't have anything with it, I'm just going to go ahead and use this one. And substitute here, again, making sure I get my parentheses in there, and I have 2. Okay, 2 times 3 is 6, minus 6y equals negative 42, and then I'm going to subtract 6 from both sides so that it stays balanced, and then positive 6 minus 6 is 0, so on the left side I get, I'm left with negative 6y, and then negative 42 and negative 6 gives me negative 48. And then to continue solving for y, divide both sides by negative 6. Negative 6 divided by negative 6 on the left side is positive 1. Positive 1 times y leaves me with just y. And then negative 48 divided by negative 6 is positive 8. And there we go. Our answer is 2 and 8. Now, I can do this if there's fractions in here, and sometimes it'll end up making fractions, but in this case, and probably a lot of your work, it'll come out with the correct answers. If you end up coming up with something like 0 equals 0, then I know that these are, because that's a true statement, I can say, oh, these are probably the same line, and they're dependent. And so it doesn't matter what I get for x, I will always get something that's correct. And so 0 equals 0, 20 equals 20, 19 equals 19. It's all right, and so it means that they're intersecting for infinite number of possibilities. If in the process you're working this out, and I don't think it'll trick you on any of your homework, it'll tell you, go ahead and solve it for an independent system. But if you do this method, just so you know, if you end up with something that is false, like 0 equals 20, then I know that these will never intersect. There will never be a possibility, and they are parallel lines. So that's one thing you just have to remember with the elimination method. If you get an answer, then you're good. If you get something true, any true statement, then they're a dependent system. Dependent, and they are intersecting every step of the way. Oh, I apparently spelled that wrong. And then if you end up with something that is not true, something false, like whatever it is, something that does not equal something else, and you've worked it out and everything's correct, then this means that they are inconsistent. All right, and so that's just something if you want to do the elimination method. And it doesn't matter, the elimination method, you can get rid of the x, you can get rid of the y, you just have to get rid of one of the variables, and it's just kind of a fast, fun way for those of you who want something different. All right, good luck on your homework.